So this exercise asks us to plot a trapezoid first of all. So part of it is just setting up a nice XY coordinate system. And you can see to simplify it, I didn't label every single point, but I did go over, 1, 2, 3, 4, and then 5. It seems like it's a little bit off, just slightly down there, but so every line is worth 1, and I've marked the 5s. Um, and then you're given a series of points to plot. The first one was that W is at 7, 3. And you can see this W clearly is over 7 up 3. X is supposed to be at 4, 3. And you can see I'm going over, you know, 1, 2, 3, 4. And then I'm going up 1, 2, 3 to get to that X. That's WX. Y is at 1, 9. So you can see I went over 1 and then up 1, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Plotted that point. And then Z was at the point 6, 5, so over 6 and up 5. And you can see that's exactly where it landed. So once this is all done, it does point out, it says, hey, remember trapezoids is a quadrilateral in which at least two of the sides are parallel to each other. If you look at it, you may be scratching your head like, geez, what sides are parallel? But if you look at this, these two sides right here, and I'll put these arrows, these are parallel to each other. And the reason why I know they are parallel, if you look closely, the slope pattern is down 2 and then over 1, right? So you can see right here, if I'm here, I go down 2 over 1. In fact, down 2 over 1, down 2 over 1. So they have the exact same slope triangle, so those opposite sides are indeed parallel to each other. So then the question is, we need to do a little transformation. It says that we need to do a reflection. We need to reflect this trapezoid across the, it says if is reflected using this transformation to form a new trapezoid where is point Y? So the question that we're asked is, where does Y go, right? Here's our point Y. Where does it end up after this transformation? If you look at it, it says, hey, Y's are going to go, if I look at this transformation, it says Y's are going to go to exactly Y's were, but X's are going to go to the opposite of X's. So when that happens, that's a transformation across the Y axis, right? So if I look at, and I'll use a different color here, point X was over 4 up 3, so I'm going to go back 1, 2, 3, 4, but still up 3. So this is my new X. W was over 7 up 3, so I'm going to go back 7, 5, 6, 7, and then up 3. The Z was back, it was over 6 and up 5, so I'm going to go back 6 and up 5. So here's the new Z. And then finally, I'm going to go back 1 and then up 9. So here's this new Y. So you can see, and I'll just kind of crudely sketch it. Right? This is the new trapezoid after this reflection. And my point Z ends up at what? X is -1, Y is 9. So that's what happens to point Y after we reflect using this rule. This rule, x's go to the opposite of x's and y's go to y's. So you can see all my x's became the opposite sign that they were. If x was over at +4, it went to a -4, etc. And the y's are still in the same spots. Now it says, part B says, name a sequence of at least two rigid transformations that will take this new trapezoid, right, this one right here, back to where it came from. And there's lots of ways you can do this, right? And it did say at least two. So you could do multiple ones. Like, for example, you could take this thing and reflect it across the y-axis and then reflect it across the, reflect it across the x-axis, then reflect across the y, and then reflect across the x-axis. Again, that's something that would be great. You can do that, and I think you could figure out those reflections looking at this rule, right, and how it did a reflection. One of the things that I did on my PDF answer that I wrote up was I said, look, let's take this trapezoid and let's take the entire thing and just transform it all 14 units to the right. So if you look at this rule, right? The y's are going to go exactly to where y's were at, but we're going to add the number 14 to all of the x values. When I do that, I get this this polygon over here that's in green. Um, from this point, this point, this point, this point, and what I said next is then go ahead and translate it across this line. This is the line x equals +7. So if you reflect it. If you reflect across that line after scooting it over 14, this thing's going to be exactly right back where it started to. So that's something else you could do. But they did want at least 2 transformations, and you can see I've mapped out 2, at least 2. But again, like I said, you could do these 1, 2, 3, 1, 2, 3 different reflections across the x-axis, and then followed by y, and then x again, and it'll get back to the same spot.